You are most welcome to MZ Math Online. MZ Math Online is an online channel where we learn mathematics. Please, if you are joining us for the first time, do us a favor by subscribing to the channel and also turn on the notification bell so that you will be notified anytime we post a new video. In today's tutorial, we are going to look at Bece 2010 question 3. So let's get to the board. This is Bece 2010 question 3A. We are asked to evaluate 2 exponent 7 times 3 exponent 4 times 5 exponent 3 all over 2 exponent 3 times 3 exponent 2 times 5 exponent 2, leaving our answer in standard form. So let's see how we can answer this question. So the question is 2 exponent 7 times 3 exponent 4 times 5 exponent 3 all over 2 exponent 3 times 3 exponent 2 times 5 exponent 2. So we can decide to rewrite the question in this form. This can be written as 2 exponent 7. The over is the same as divided by 2 exponent 3 multiplied by 3 exponent 4 divided by 3 exponent 2 times 5 exponent 3 divided by 5 exponent 2. So this is another way we can write the question. After that, you can see that there's division sign in all the brackets. So we apply the division law to each of them. So applying the division law of indices, the law says that if the bases are the same and you are dividing it, you pick one of the bases and then you subtract the powers. So doing so, we have 2 exponent 7 minus 3 multiplied by 3 exponent 4 minus the exponent 2 here minus 2 multiplied by 5 exponent 3 minus this 2. After that, we can simplify this as 7 minus 3 is 4. I have 2 exponent 4 times 3 exponent 4 minus 2 is 2 multiplied by 5 exponent 3 minus 2 is 1. So this will give us 2 exponent 4 is 16 multiplied by 3 exponent 2, which is 9, multiplied by 5 exponent 1, which is 5. When you multiply all the 3 numbers together, you are going to get 720. You can cross check that and see. Now, remember that we have to leave our answer in standard form. So because we have to leave our answer in standard form, we need to write this in standard form since 720 is not in standard form. Now remember that for a number to be in standard form, it should be a number between 1 and 10 multiplied by an integer power of 10. So since 720 is more than 10, it is not in standard form. So we have to write it in standard form. So this implies 720 in standard form. So since there is no decimal in the number, it is same as 0.0. So 720 is the same thing as 720.0. So you put the decimal point in between the first 2 significant figures, which is 7 and 2. So you count 1, 2. So counting from your right to your left is always positive. Moving from right to left is always positive, and moving from left to right is negative. So we have moved 2 times, so that will be positive 2. So 720 can be written as 7.2 multiplied by 10 exponent 2. That is how we can write the answer in standard form. And that answers the first part of question 3. This is the second part of question 3. That is question 3b. In question 3b, the question is asked that Kwame rode a bicycle for a distance of X kilometers and walked for another half hour at a rate of 6 kilometers per hour. If Kwame covered a total distance of 10 kilometers, find the distance X he covered by the bicycle. From the question, the distance covered by the bicycle is given as X kilometers. So we can see that distance covered by the bicycle is given as X kilometers. Now, in the question, we are told that he walked for another half hour at a rate of 6 kilometers per hour. So this is the time and this is the rate at which he walks. So we need to find the distance that he walked. Distance let me just simply say distance by walking, or distance covered by walking, equal to the time he used in walking multiplied by the rate at which he walks. So half multiplied by 6 will give us, simplifying this, 2 to yourself 1, 2 here, 3 multiplied by 1 is 3. So that we have 3 kilometers. That means that Kwame walked at a distance of 3 kilometers using a time of half hour, and the rate he used was 6 kilometers per hour. Now, we know that the total distance covered by Kwame will therefore be, so total distance will be equal to, let me just say, bicycle distance, to cut it short, bicycle distance, that's the distance he covered using the bicycle, plus the distance he covered walking. So let me just say walking distance. You can write that in full. I'm just trying to summarize it for the sake of time. Meanwhile, we are told that the total distance he covered is 10 kilometers. So the total distance is given as 10 kilometers. We will therefore have 10 will be equal to the bicycle distance, which is known as X kilometers. So I have X plus the distance he covered walking, that is 3 kilometers. So I have plus 3. So we are going to make X the subject. Making X the subject, we group like terms. So we therefore have grouping like terms. We have 10 minus 3 is equal to x. So that therefore x will be equal to 10 minus 3, and that will give us 7. X will be equal to 7. So in conclusion, the distance Kwame covered by bicycle is equal to 7 kilometers. Therefore, the distance covered by bicycle, the distance covered by bicycle is equal to 7 kilometers. So that is how we find the distance that Kwame covers by the bicycle. That's the only question we are asked to find as far as the question is concerned. So there's no any other question as far as this particular question is concerned. And that is the second part of the question 3. Now let's look at the last part of question 3. Now question 3c. In question 3c, the question is as follows. A rectangular tank of length 22 centimeters, width 9 centimeters, and height 16 centimeters is filled with water. The water is poured into a cylindrical container of radius 6 centimeters. Calculate the I volume of the rectangular tank, II, depth of water in the container. Take power equal to 22/7. Before we answer this question, I would like to say one or two things about the question. Now, the first part of the question says we should find the volume of the rectangular tank. We must note that when they say rectangular tank, they are actually referring to a keyboard. Now, the second part I want to mention is this water that is filled with the tank, that is filled with water. The water inside the container is actually filled to the brim. That means that the water is occupying the space of the keyboard fully. Now, because of that, the water that is inside the container will have the same volume as the volume of the rectangular tank. And then the last part I want to mention is we have to find the depth of water in the container. If you have to find the depth of water in the container, the question is actually asking you to find the level of the height of the cylinder that the water will occupy. That means at what level of the cylinder will the water stop when you actually pour it into the cylinder. You should bear in mind that when you poured water from the keyboard, which was fully filled with water, it does not necessarily mean that when you pour it onto the cylinder, it will occupy the cylinder too. So the question is actually asking you to find the level at which the water will end inside the cylinder. Now let's get started. The first part of the question, we have to find the volume of the rectangular tank. So we have CI, volume of rectangular tank which is a keyboard, as I mentioned earlier on, equal to length times width times height. This is the formula we use to find the volume of a rectangular tank or volume of a keyboard. Now in the question, we are told that the length is 22 centimeters. So we have 22 centimeters multiplied by the width, which is 9 centimeters, multiplied by the height, which is given as 16 centimeters. So now multiplying 22 by 9 by 16 will give us 3,168 centimeter cube. So here we have 3,168 centimeter cube. We have centimeter cube as a unit of measurement of volume. Note that if you multiply centimeter by centimeter, you get centimeter squared, and centimeter squared times centimeter will give us centimeter cube. So that's where the cube is coming from. That is the first part of the question. The second part of the question, we are asked to find the depth of water in the container. So, as I already explained at the beginning, since the water was filled to the brim of the rectangular tank, the volume of water will be equal to the volume of what? The rectangular tank. So that means that this is the volume of the rectangular tank, and that will also be equal to the volume of the water that is going to be poured into the what? Into the cylinder. So, but we know very well that pi r squared h is the formula we use to find the volume of cylinder. That is the formula we use to find what? Volume of a cylinder. So pi r squared h is equal to volume of a cylinder. So this volume of a cylinder will be equated to the volume of the rectangular tank, which is also equal to the volume of the water, so that we can be able to find the depth. So finding the depth will actually mean that we are finding what? The height. So the question, instead of asking us to find the height of the cylinder, they said we should find the depth of water in the container. Indirectly, they are actually asking us to find the what? The height of the cylinder. So equating this formula to the volume of water, we will have, meanwhile, pi in the question is given as 22/7. I have 22/7 multiplied by the radius of the cylinder, that is the base circle, which was given in the question as 6 centimeters. So we have 6 centimeters squared. That will be equal to 6 multiplied by 6 multiplied by the height, which will be equal to the volume of water. And the volume of the water is the same as the volume of the rectangular tank, which is 3,168. I believe you are following up to this stage. Now let's continue. So multiplying 6 by 6, we have 22/7 multiplied by 36, that's 6 times 6, multiplied by the height will be equal to 3,168. Over here, I want to clear the fractions. By clearing the fractions, I'll multiply both sides by 7. Over here 2 by 7. So that this 7 will do away with this 7, leaving 22 multiplied by 36 multiplied by height, which is equal to 3,168 times 7. All right. Yes. Over here, we could multiply these two together and multiply this together. But I don't want to multiply for now. If you multiply, you actually get a correct answer. But we'll have some big numbers in quotes. And I know students, you don't like dealing with big numbers. That's why I have decided not to multiply. I want us to simplify them first before we now multiply. But those of you who are allowed to use calculator, those at the senior high level, you can decide to multiply them. But those are the basic level. You are not allowed to use calculator in the exam hall. So that's why I don't advise my students to multiply this, so that they will be dealing with big numbers and you find it difficult breaking down the fraction. So with this, I'll just divide both sides by 22 times 36. Divide here 2 by 22 times 36. So that this 22 will do away with this 36, will do away with 36, leaving each equal to. So now let's try and break down the fraction. Now 22 can enter into 3,168 114 times. So 22 into itself, 122 here, we have 144. When you check very well, you can see that 36 can also enter into 144, and 36 will enter into 144, I think 4 times. So 36 into itself, 136 here, 4. You can do your cross check to see whether the answer is right or not. You now multiply 4 by 7. 4 multiply by 7, and that will give us 28. The unit is centimeters. 28 centimeters. So you can therefore conclude that the depth of water in the container will be equal to what? 28 centimeters. Therefore, the depth of water you can add in the container equal to 28 centimeters. And that brings us to the end of question 3, 2010 EEC past question. And that also brings us to the end of today's lesson. Please, those of you who are yet to subscribe to the channel, let's try and do so that we'll grow our channel together. Until we meet again next week, bye for now.